Namaste friends, I welcome you in this today's lecture. Today we are going to discuss about the equilibrium constant and the extent of the reactions. So let us discuss about this. As we know, the equilibrium constant depends upon the concentration of the reactant and the products, as well as a chemical reaction, whether it takes place in a forward direction or in a backward direction. It depends on the Gibbs free energy. In previous lecture we have seen what is meant by Gibbs free energy. Okay, free energy is what? It is the energy available to do the useful work is called as a free energy, and if we measure this free energy, that is energy available to do the work at constant pressure, then it is called as the Gibbs free energy. And if we measure this energy available to do the work at constant volume, then it is called as Helmholtz free energy. We also know that this Gibbs free energy depends upon the concentration of our reaction mixture or the concentration of reactant or the products. Now, when delta G is less than 0, delta G its value is less than 0, below 0, then the reaction is spontaneous in nature. Spontaneous means it will happen automatically, okay, happen on its own accord. Okay. Now, the tendency of any reaction to go in forward direction or reverse direction depends upon the concentration of reactant and the products. So, how this how the concentration of reactant or product affect on our chemical equilibrium capital K or equilibrium constant capital K, that we will see. Okay. Now, let us focus your attention here. Okay. This is the equilibrium reaction where the reactant A and B are converted into the products C and D, and this is the equilibrium arrow. This is the chemical equilibrium. What is the chemical equilibrium? It is the point or it is a state at which there is concentration of reactant and product remains same and it do not change with time. The point at which concentration of reactant and products remains constant with time is called as chemical equilibrium. Now, this is the chemical equilibrium arrow, and as we know that in previous lecture we have seen, please watch the previous lecture, the equilibrium constant at this point capital K is equal to product of concentration of this product C and D and product of concentration of this reactant A and B, or in general language we can say that it is the ratio of concentration of product divided by concentration of the reactants, right? Now, when this concentration of product and concentration of reactant both are equal, okay, when both are equal, then our capital K is equal to 1. Okay, it means that equilibrium constant value is equal to 1 because both are the same. Second case, when concentration of product is more than concentration of reactant. Concentration of product is more than concentration of reactant, then capital K value is greater than 1. Here concentration is product is value is more than that of reactant. So, this ratio will have more than 1 value. Okay. And if reactant value is more than that of concentration value, then K value will be less than 1. Here case number 3. When concentration of product is less than reactant, then K value is equal to 1. Now, let us understand these 3 cases with the help of graph. Just look at the first graph. Okay. This graph is free energy versus reaction progress. Free energy versus reaction progress. Now, here the free energy decreases till this point. Okay, and this point is called as the equilibrium point. This point is called as the equilibrium point. And at this point, equilibrium point, the free energy change delta G0 is equal to 0. Okay, K is equal to 1. So, there is no free energy change at the equilibrium point. Along this line, the free energy decreases, or we can say this is the delta G less than 0. Okay. Therefore, the reactants gets converted into the product along this line. Okay. and at this point there is the complete formation of the equilibrium. So we can say that the concentration of product and concentration of product and concentration of reactants remains same with time. Okay, if we increase time, there is no change in this equilibrium constant value, k is equal to 1. Now as you go on from this side, okay, here this side is pure reactant side and this is the pure product side. Okay, so when you come to this point along this curve, then 100% product is formed. Okay, actually in this equilibrium reaction no product are formed in 100% ratio. Okay, so as you go down here, the free energy increases, delta G is greater than 0. When this delta G is greater than 0, it means that, okay, the reaction will not go in opposite way. When free energy is less than 0, okay, only then reaction go in that forward manner or reactant will get converted into product. When free energy is greater than 0, then opposite reaction will not takes place. Remember this. Okay, so this is the equilibrium arrow. Now let us come to this second case. Okay, we have seen the first case. Now second case, when the product concentration is more than that of the reactant, then K value is greater than 1. Okay, in this case the more amount of product is formed in the reaction. So here this case is, this is the case, K is greater than 1. Okay, so reaction is product favored, we can say it is a product favor and it is the less reactant favored. Look at this arrow carefully. Okay, forward reaction is favored and backward reaction is least favored, and here this point we have, this is the equilibrium point, delta G 0 is equal to 0 in this case. Okay, and along this free energy there is less than 0. So this reaction is more favored, forward reaction is favored, or we can say that the reaction is product favored. Reaction is the product favored. Okay, here, so this is the below the equilibrium arrow, this is the what, spontaneous reaction, we can say that this point, this is the spontaneous reaction takes place, and along this point delta G is greater than 0. Okay, it means that, okay, this point is what, pure product and pure reactant. Product will not again convert it into the reactant. There is least preference to convert this product into the reactant. Okay, because the free energy is more. Product are in this case more stable than the reactant. So product will not convert it into the reactant. In free energy language, we can say that the free energy is more than that of the reactant. So delta G is greater than 0, here delta G is less than 0. It means that reactant have less stability than product, so their free energy, they will spontaneously react to form the product. So the reaction is there is decrease, sharp decrease in this curve. Okay. Now third case, look at the third case, when the concentration of product is less than that of the reactant. Okay, it means that K is equal to 1. हा जर रेशिओ आपण बघितला, हा प्रोडक्टचं कॉन्सन्ट्रेशन आहे आणि हे रिॲक्टंटचं कॉन्सन्ट्रेशन आहे. जर हे लेस असेल प्रोडक्ट कॉन्सन्ट्रेशन, तर डेफिनेटली के ची व्हॅल्यू काय येणार आहे तुमची, जास्त सॉरी लेस दॅन 1 येणार आहे, बिकॉज रिॲक्टंट व्हॅल्यू इज मोर दॅन दॅट ऑफ द प्रोडक्ट्स. Okay, so K value will be less, and this is shown by the graph. This is the middle graph. Okay, here this point is the equilibrium point. Equilibrium point. Equilibrium point, equilibrium point. So here you observe carefully that, so this reaction, okay, here delta G is greater than 0 and here delta G is greater than 0. It means that, okay, what will be the answer here in this case? The reaction is more backward favored than the forward favored. Okay, this is the backward favored, or we can say this is the reactant favored. reactant, okay, the reaction is the reactant favored. Here this is delta G is less than 0 up to this. So what is the physical interpretance, okay, interpretation? It means that our reactants are more stable than that of the product. Reactants are more stable than that of the products. Okay. So these are the three conditions where we have seen in this lecture: equilibrium constant and extent of the reaction. What you must understand in this reaction, okay, the more stable reactant or products, okay, gives rise to the corresponding equilibrium constant value. Okay. So here this is the first graph, second graph and the third graph. First graph, okay, this is the equilibrium will be located at the middle here. So there is the establishment, equilibrium established as early as possible. Here the reaction is backward favored, reactant favored, and reaction is the product favored. Okay. So if you have any doubts, then please watch this lecture again and again, or you can WhatsApp me or you can call me. Thank you for watching this session.